In this video, we'll talk about how to divide complex numbers. So let's say we have 3 plus 5i divided by 1 minus 2i. How can we perform this division problem? Well, it turns out that when we're dividing complex numbers like this, the trick is we can multiply both the numerator and the denominator by the conjugate of the denominator. So what's a conjugate? Well, if we have an expression like this in this form, a plus bi, the conjugate is a minus bi. So in the denominator we have 1 minus 2i. The conjugate of that would just be 1 plus 2i. So we can multiply both the numerator and the denominator by 1 plus 2i. So let's go ahead and do that. So in the numerator we have 3 times 1, and then we have 3 times 2i, so that's 6i. And then we have 5i times 1, that's just 5i. And then we have 5i times 2i, that's 10i squared. 10i squared. So that's what we have in the numerator. And the denominator, we have 1 times 1, and then we have 1 times 2i, so that's 2i. So we did that. And then we have negative 2i times 1, that's minus 2i. And then we have negative 2i times 2i, that's negative 4i squared. So now we just need to simplify. So in the numerator we have 3 plus, we have a 6i and a 5i, so that's a 11i. So plus 11i. And then we have plus 10i squared all over. Now here in the denominator, this plus 2i and this negative 2i cancel out. So we have 1 minus 4i squared. Now when we're working with I, we need to remember I is equal to the square root of negative 1, and I squared is equal to negative 1. So what we've really got up here in the numerator, let's rewrite it as 3 plus 11i plus 10i squared, that's negative 1. So that's a negative 1 that we're multiplying by. And then we have 1 minus 4i squared. Remember, I squared is negative 1, so this is just a negative 1. So if we simplify, 10 times negative 1, that's negative 10. So we have a 3 minus a 10, that's a negative 7 plus 11i. All over 1 minus 4 times a negative 1, so that's 1 plus 4, which is 5. So this is our final answer. If we want, we can write it in what's known as standard form, where we write a constant first, so that's negative 7/5. And then we write 11/5 times I. So this would be our final answer. All right, let's try another example. Let's say we have 7 plus 3i over 4i. So once again, we want to multiply the numerator and the denominator by the conjugate of the denominator. So for this one, remember when we have a plus bi, the conjugate of that is a minus bi. Well, in this case, the denominator doesn't have an a, so the bi is just 4i. So we would multiply by negative 4i. That's the conjugate. So let's multiply the numerator by negative 4i, and let's multiply the denominator by a negative 4i. So in the numerator we get 7 times negative 4i, that's negative 28i. And then we've got 3i times negative 4i, that's negative 12i squared. All over 4i times negative 4i, that's negative 16i squared. Okay, so to simplify that, let's recall that an I squared is just equal to negative 1. So up top in the numerator we have negative 28i minus 12 times a negative 1. And then in the denominator we've got negative 16i squared. So I squared is negative 1. So negative 16 times negative 1 is a positive 16. So we get negative 28i. A negative 12 times a negative 1, that's a positive 12. So plus 12 over 16. And we usually like to write this answer in standard form, so that's where we write the constant first. So that would be 12 over 16 minus 28 I over 16. So we can reduce these fractions a bit, and we'll just write 12/16 is 3/4. And then over here we can divide the numerator and the denominator by 4. So 28 divided by 4, that's 7. 16 divided by 4 is 4. So we'll write 7/4 I. And that will be our final answer. Thanks for watching.